Okay, are you able to see my screen with the fire prevention slides?
Yeah, it's all right. You can start.
Okay, all right, then we'll go ahead and get started. Okay, um, hello, I'm Elizabeth Brown with the International Board of Safety Professionals. Today we'll be reviewing a presentation on fire prevention and protection. This is found in the OSHA standards under the general industry standards, which are found in the subpart 1910, or in part 1910, subpart L. Let's see. Sorry. I'm going to do this on my laptop. It was a little special today. Okay. So we'll see here that first we have a definition for what is a fire. And a fire is a chemical reaction which occurs when fuel, oxygen, and an ignition source are brought together. We can see here that a fire is actually a rapid chemical reaction that is typically fueled by an oxidant or an oxidizer. It is accompanied by a release of energy, which is indicated by the flame that we actually see. So a lot of people don't really necessarily think about fire as a chemical reaction that it is, and it's this release of energy. I think a lot of us just tend to think about fire as the flame that is that energy that is produced. We can see the chemical reaction and the formula there. When we have the reaction that occurs when carbon combines with oxygen, and actually that you see plus the formula of water there. Okay, so something that you might be familiar with, a little bit more familiar maybe than the chemical formula of fire, is the fire triangle. And so you can see here that we have to have all three elements of the fire triangle to successfully have a fire. There are times that it's a good thing that we want to have a fire, and then we'll also talk about the times that mostly our presentation will focus around prevention of fire. So the three things that we must have for a fire are, as mentioned earlier, a fuel source, heat, and then oxygen. So we must have oxygen for that combustion to occur. And those three things make up the fire triangle. Those are the three things that are needed to successfully have a fire. I think those three things are important to note that are needed to have a fire, so we also can focus on how to prevent fire or how to successfully extinguish a fire if we do have one that we do not want to have. So we can minimize physical property damage and minimize injury and protect our employees or loved ones or whoever it might be where the fire is occurring. So if you take away any one of those three elements, so either oxygen, if we remove the oxygen from the fire by smothering it, or even removing oxygen from a room, that could successfully remove a fire. But we have to be very careful in those situations. If people are in that room, we don't want to remove the oxygen. So then that becomes an environment where they cannot breathe. We also can cool the heat of a fire, and we also can remove the fuel source of the fire. So again, smothering the fire, which would reduce the oxygen, starving the fire by reducing the fuel, and then cooling the fire by reducing the heat. And we'll see in a bit the different types of common fire extinguishers that we have that successfully help to extinguish fires by doing one of these three things, by removing one of these three elements in the fire triangle. So in terms of smothering or reducing the oxygen for fire extinguishing, This method cuts off the oxygen supply. So you'll see these with, see this occurring when we have a type of foam or an extinguishing agent that's like a foam, or I've seen in certain situations where you might have electrical equipment or a control room, electrical control room or motor control room, where that equipment cannot get wet. Then you might see a carbon dioxide system being used for a fire extinguishing method. And that would work by either ensuring that the employees were available to access the room when the method was being utilized, or employees would be required to wear an air supplied respirator with an oxygen tank on it if they were going to be going into the area. The next method with cooling, so reducing the heat, it allows the fuel temperature to be lowered by removing the heat. So some pretty basic fire extinguishers that have been in existence for a long time. Probably the first methods of fire extinguishing would be just to apply water to the fire to reduce the temperature. We'll talk in a bit about situations where, and we just did a minute ago, there are situations where applying water could cause an even worse situation to occur. So we want to make sure that we understand what is the source of the fire, and we make sure we're using the correct fire extinguishing method. In particular, electrical fires, certain kitchen fires, and then also any type of combustible metal. If we apply water to these in these situations, it could certainly make the situation much worse than just the fire itself. So we want to be careful to use the correct fire extinguishing method. We also have starving or reducing the fuel. So this approach involves depriving the fire of fuel. So a great example of this is if we have a fire occurring in a pipeline, then we stop the gas flow, or we stop whatever chemical it is that's flowing through the pipes, whether it be natural gas or crude oil, whatever the case may be. We stop the flow of that down line, and that would deprive the fire of fuel. We also can stop the ignition and inhibit the chain reaction. So we can do that by applying a dry chemical powder that's commonly used. If you've seen just your common ABC red fire extinguisher, these typically use a dry chemical powder that can stop the chain reaction for our three most common fires. So our combustible materials, common, refuse like wood, paper, things like that. An ABC dry chemical powder would be applied. Okay, so when we talk about fuels, we might think of fuel for an automobile, and that's certainly, gasoline is certainly a very flammable liquid. But when we're talking about fuel for fire, we're thinking about any type of combustible material or substance that can be consumed to continue that fire triangle, that fire combustion process. And in typical workplaces, simple things like we talked about a minute ago, paper, cardboard. We get a lot of cardboard in packaging in workplaces. Wood, maybe for pallets, crates, things you might use for shipping. Also just soft furnishings, other structural materials. Those all are very common things that we don't see as dangerous, but we want to be careful that we are not allowing those to accumulate in large amounts in areas, that we're ensuring that we're throwing these things away or recycling them appropriately. And also, especially keeping any type of combustible materials away from open flames, welding, any type of painting operation where we have high amounts of flammable liquids, are all areas where you want to minimize these chances of these combustible materials accumulating. And then obviously we have things like flammable liquids. A lot, when I mentioned a painting operation, because we have a lot of thinners and solvents that are being used in these operations. Also, our welding fuels, our compressed gases like acetylene, butane, as well as just your oxygen that might be used in electric arc welding. Those gases can either be aid in the oxidation process and be an oxidizer, which means that they are contributing to the combustion of the fire. So all of those things need to be stored properly so that we ensure that we're not contributing more to this potential for fire. So as mentioned, part of the fire triangle is oxygen. So it is consumed during the combustion of the process, and combined with fuel can cause the fire. We naturally have a concentration, an average concentration of oxygen in our air at 21%. But during a fire, oxygen can also originate from other sources. So we talked about our compressed gas cylinders, like you see here in the picture, that has oxygen in large quantities. There's also other mixes of gases that can be termed oxidizing agents, like ammonium nitrate, that can contribute to that fire triangle and to combustion. All right, heat and other ignition sources like a spark from a welding arc or slag from welding, even the static electricity can cause enough spark to ignite a vapor of a flammable liquid. Once combustion is started, it generates its own heat, and this usually is sufficient enough itself to keep a fire burning. So once a fire starts, the heat source can be removed, but there's enough strength to that chemical reaction that the fire creates its own heat and creates its own fuel source. It's feeding on itself at that point enough to stay alight. So when we look at extinguishing a fire, it's important to note that once the fire has gone out, we need to ensure that we have a fire watch for 30 minutes is a good time after, to make sure that the fire doesn't possibly reignite, because that has been a very common thing to occur. We have classification of fires. It's important to know, again, what type of fire we're dealing with, and we typically classify that based upon what the fire's fuel source is, and we will see those different classifications in a minute. But it's very important that we know the classification of the fire based upon its fuel source, so that we can utilize the proper extinguisher to put that fire out. Because as I mentioned earlier, we could have even worse results, even worse disaster, if we utilize a water or another liquid extinguishing source for things like electrical fires, kitchen fires, and combustible metal fires. Those can cause even worse situation to happen. So our 5 classes of fire classification, as you see here, are related to the type of extinguishers that can be used. So our class A fire is what we call our ordinary combustible materials. So it involves wood, paper, cloth, just general household or business trash, plastics that are not, and solid plastics that are not metal. A class B fire is going, I always remember B for, and relate it to boiling. So B for boiling reminds me that things that boil are a liquid. And so class B fires are things that are flammable liquids like gasoline, oil, grease, solvents like we talked about earlier, maybe acetone, toluene, things that we commonly see in painting operations and other operations as solvents or thinners. And boiling also includes flammable gases. So when we looked at our compressed gases, like acetylene is a flammable gas that's commonly used in welding operations. That is obviously also going to be a flammable source if for a fire. Class C are fires involving electrical equipment. So energized electrical equipment that is live or plugged in. We would use a Class C electrical extinguisher for that. And those are specifically made to be used around electrical equipment. A Class D fire involves metals, so potassium, sodium aluminide, aluminum, magnesium. They require a metal X foam, which is a special extinguishing agent for combustible metals. So it's important to know what type of metals you're working with. I think a lot of people are not aware that aluminum dust, that's in particular another thing to consider. Combustible dust that originates from something like, say, aluminum can, when accumulated, can cause explosions when we have a fire that starts in an enclosed space, and that has caused horrible disasters for in certain areas for different companies. Also, if anyone works in metal foundries, we have large amounts of magnesium, potentially that have heard of fires occurring. And this is when it's important for not just your emergency response team to know at your business how to manage the fire, but to also work with your local fire department and agencies to make sure they understand. And I worked with a large pipe manufacturer, steel and ductile iron pipe manufacturer, that had a large fire breakout where there was molten magnesium being used, and the fire department was not aware, and they rushed onto the scene and were about to try to extinguish that fire using their water on their truck, and that would have caused an actual explosion if that had occurred. Thankfully, somebody on site was able to get to the lead of that fire department team and stop that from happening before it occurred. Lastly, we have Class K. This is for just K for kitchen. This is for cooking oils and fats. If you ever have a grease fire in your home, I hope everyone knows that you should never try to extinguish that using water. That's another situation. Essentially, you can remember Class C, D, and K should never have water applied to it to extinguish it. Because again, that can cause the oil and water do not mix, and oil that's on fire, and you throw water on it, it can just cause that fire and burning oil to be splashed around, and causing the person that's trying to extinguish it to be injured, typically very severely. We don't have Class K extinguishers available for our homes. They are meant just for commercial kitchens and restaurants, food processing facilities. They have to be utilized along with a permanent system that is engaged that helps to extinguish that fire. So very, very especially made for those situations. Okay, so we saw Class A fires. This is typically what you might see is a picture here of this looks like an apartment building on fire. This is our ordinary combustible materials such as wood, cloth, paper, rubber, plastic, just things you might find in a household or a business outside of the other materials we see for processing. Water is what we typically are going to use in Class A fires, but we will see that we have a Class a multi-use class A, B, and C fire extinguisher that are the common extinguishers we see in a lot of workplaces that put out class A, B, and C fires. And they do not have water though, because we saw that we cannot use water on a class C fire. So class A also can use a foam that can enhance water's ability to extinguish class A fire. So this is done by cooling the heat that we saw was one of the legs or parts of the fire triangle. Class B fires involve flammable and combustible liquids and gases such as gasoline, oil, lacquer, paint, mineral spirits, any solvents that we saw, alcohol. In the Class B fires, we want to smother or use the blanketing effect to try to minimize how much oxygen is available to feed the fire, as well as to help reduce any production of any of the vapors, because the vapor itself is what's initially ignited for a flammable liquid to then further catch on fire. Other extinguishing methods include removal of fuel and temperature reduction. Class C fires, as a reminder, is when we have an electrical fire that's been started by live or energized electrical equipment. I think and hope we all know that two big things that do not go together besides oil and water, or it's also water and electricity. Actually, electricity likes water a lot. It's a conduit for electricity. So we want to avoid putting water on any type of live electrical equipment. If we did, then that can increase largely our chances of being electrocuted. So instead, we can use systems that utilize carbon dioxide, which again, if we do that, that eliminates the oxygen source of the fire, but it also can eliminate the oxygen source for the people utilizing that equipment. So we need to ensure that our firefighting personnel are protected if we are using a carbon dioxide as an option for these fires. The more common option that we see is dry chemical extinguishers with those A, B, C combination extinguishers. If possible, this is important, we want to de-energize the electrical equipment before attempting to extinguish the fire. This can be done, and this is why it's very important for all of our electrical equipment to be labeled as to what equipment it is de-energizing. So whether it's a breaker panel or a disconnect, we need to be able to access that in emergency and disconnect or de-energize the energy source. Class D fires involve flammable metals, as we talked earlier, like magnesium, titanium, sodium, potassium, and lithium. These fires can be extremely dangerous. They burn at very high temperatures and can react violently, as mentioned earlier, with water and other substances. So if fighting a Class D fire, we would use a special type of extinguishing agent, such as a dry powder, sand, or some other type of special extinguishing agent that has been specifically designed for the type of metal involved. These agents work to smother the fire and cut off the oxygen supply. Again, to say it again because it's that important, we must avoid using water or foam on a Class D fire because these agents can react with the metal and potentially make that bad situation with the fire much worse. And this is a great illustration of a picture of a fire occurring, looks like in some type of foundry situation where you have a large vat or a large amount of molten metal. Our Class K fire, I always think Class K equals kitchen fire, involves cooking oils and fats. But these, when we think of these, it's typically in commercial kitchens, in restaurants, and food processing facilities. These fires can be just as dangerous as anything else because it involves cooking oils and fats that also can reach very high temperatures, can ignite quickly, and should not be attempted to be extinguished with water. So the Class K extinguishing agent is designed to cool the fire and prevent reignition. It's used with a wet type of chemical extinguishing agent that are specifically designed to work with cooking fats and oils. And it creates a barrier between those oils and fats and the oxygen supply. So it helps to smother out the fire and prevent it from spreading, because oils and fats, the more they heat up, they get liquefied and they can spread out, and the fire can grow very quickly. Okay, so we've talked about fires and the 5 different classes. Let's look at the 3 most common types of fire extinguishers. So one we've mentioned is water, and you might see that as an abbreviation, APW. It's a pressurized water system that's in a contained fire extinguisher, like you see in this picture here. Second is carbon dioxide, and third is a combination of a dry chemical. And so you might see that abbreviation as ABC, and that stands for that it's for all 3 of those common types of fires. So our A, normal combustibles, B, flammable liquids and gases, and then C, combustible metals. And then you might have a combination of BC, or then, or I'm sorry, C is electrical equipment, or you might have a combination DC. So our water fire extinguishers, you're gonna see them. You might see, again, like in the picture here on the left, it says APW. That is just telling you that it's pressurized, air pressurized water in the tank, and it has a gauge, just like all portable fire extinguishers have a gauge to ensure that we're checking it and making sure that we have sufficient pressure, because we want to make sure that we have enough pressure to have the agent, the extinguishing agent, whether it be water or dry chemical, whatever the case may be, that can with enough pressure to get to the fire without putting the person that's using it in danger. So it allows the person to be able to stand at a safe distance while extinguishing the fire. These are filled with just ordinary tap water, and they're pressurized with air, and they are essentially like large squirt guns. It just put a large amount of water out. They typically stand about 2 feet tall. Again, they're in a silver container and weigh about 25 pounds when they're full of water. These are only to be used with Class A fires, so just the wood, paper, cloth type things. They should not be used to put out any other type of fire. If we use water on electrical fires, that can increase our chance of being electrocuted or experiencing electrical shock. We should not use it on flammable liquid fires. We should not use it on metal fires or kitchen fires. Carbon dioxide fire extinguishers are the only ones that don't have a gauge. So the pressure in the CO2 extinguisher is so great that bits of dry ice might shoot out of the horn. I've not personally seen these being used in workplaces. But if you're another type of gas that you might be similar to this, you might be familiar with, is liquid propane or LP gas. Sometimes those can also, with their pressure, can be very cold. So you need to be very careful when using these. The CO2 cylinders are red. You can notice the differences in them. Besides the label saying CO2, in the red exterior, if you see around the handle, there's no gauge, and it has a hard horn for the where the CO2 would come out when we engage the lever, and that allows the person that is using the extinguisher to be protected. These can range in size from 5 to 100 pounds or larger. So you can see that these are going to be used for very specific purposes. Any of the extinguishers, when we have a range in size, obviously the smaller end, the 5 pounds, would only be able to extinguish a certain size fire or for a certain amount of time. And then towards the larger end, the 100-pound extinguisher would have a lot more CO2 in it and would be available to be used for a longer period of time. So carbon dioxide fire extinguishers are designed for Class B and C fires only. Again, because it removes the oxygen from the room, we want to make sure that any employee that works in that room is very aware of our emergency action plan and our firefighting plan, and making sure, so we typically would only see these in areas where they would be needed, like laboratories, mechanical rooms, kitchens, flammable liquid storage areas where we can't use water or any other extinguishing source. So they would be needed, but we try to avoid them when possible because of the harm and potential harm to employees. So we must make sure that these are maintained in accordance with the National Fire Protection Agency regulations, as well as the manufacturer recommendations. They must undergo hydrostatic testing and be recharged every 5 years. And there should be, in just about any place I've been, a local company that their business is to sell and maintain fire extinguishers. So companies, I've known larger companies that have decided to buy the hydrostatic testing and buy the equipment that can recharge the extinguishers, but for the most part, companies choose to do this service through a contractor. So carbon dioxide, fire extinguishers, how they work. Carbon dioxide is a non-flammable gas, but it does take away oxygen from anything it's exposed to. So that's why it's very effective in controlling a fire, because it removes the oxygen from that fire triangle. CO2 is also very cold, like we mentioned earlier, so it helps to cool down the temperature or the heat of the chemical reaction. But again, it might be ineffective, and we don't want to use it in a Class A fire, because in those types of fires, it might not be effective in displacing enough oxygen to be able to successfully put the fire out. So in Class A materials, they might smolder because if they're not fully, if all the oxygen is not displaced, they might smolder and reignite. So it's better to use a different type of material, like a dry chemical fire extinguisher, or what we commonly call an ABC fire extinguisher. So dry chemical extinguishers put out fire by coating the fuel with a thin layer of dust, and this separates the fuel from the oxygen in the air. The powder also works to interrupt the chemical reaction of fire, and so this makes these extinguishers very effective at putting out Class A, B, and C fires. So again, you might see them labeled as DC for dry chemical, but that doesn't mean that they're meant to be used for Class D fires. So that's something that it could be potentially confusing. It just means dry chemical, but you will also see that it'll be labeled for the types of fires that they are designed to be utilized to extinguish. So ABC is what I've most commonly seen, or you might see just BC, so meaning they're designed for the flammable liquids and gases, as well as electrical fires. So they're also red and have a handle and a lever and a pin that helps you to from the fire extinguisher from accidentally being engaged. But they do have gauges on them, so that is one thing that makes them stand out different from the CO2 extinguishers. The ones I've seen all have a hose of some length and then kind of a nozzle on the end, but it is a fine powder that is under pressure. So there's like a little piece of a pie, like a triangle on the gauge that's green. And there's a needle, and you want to ensure that the needle stays within the green triangle. And that tells you that your fire extinguisher has the correct amount of pressure, because those fire extinguishers can lose pressure and be under pressurized, but they also can, like if they're in an area with heat or exposure like that, they can become over pressurized as well. So we want to make sure that the needle is in that green zone at all times. ABC fire extinguishers are red, like we mentioned. They do range in size from 5 to 20 pounds. The greatest portion of the powder that's in the fire extinguisher is composed of monoammonia phosphate. So this doesn't displace oxygen, so it's safer to use with people. They can stay in the room. It just works to create a barrier between the fire and oxygen in the room. The extinguishers are pressurized with nitrogen. So to use a fire extinguisher, it's easy to remember how to use a fire extinguisher if we remember the acronym PASS. And so PASS stands for, the P represents pull the pin. So as I mentioned, all fire extinguishers have some type of pin engaged with a ring on it, as you can kind of see in the diagram number 1 at the bottom left. That keeps the fire extinguisher from accidentally being engaged, and it's easy just to loop a finger through the loop and pull the pin out. Once we've pulled the pin, we want to aim the nozzle at the base of the fire. This is something that I've experienced when teaching employees how to respond to a fire, doing a hands-on demonstration, like in the picture here. A novice or new employee that's never utilized a fire extinguisher before tends to want to aim the nozzle at the top of the flames and sweep across the top of the flames. But just remember that we want to aim at the base of the fire, because that's where the core of that chemical reaction is occurring. And we want to get the extinguishing material at that base to either displace the oxygen or get that powder from an ABC extinguisher at the base and the core of the fire and the source of it to protect the fire, create that barrier around the fire and from the oxygen in the room. After we've aimed, we want to squeeze the lever. So our hand, with a part of the fire extinguisher we're holding with the handle, we want to pull the lever and squeeze it, and then sweep from side to side at the base of the fire. And we would continue to do this until the fire is out, which at that time we would want to just stay there as long as we still have material in our fire extinguisher, and observe the area to ensure that there's no reignition of the fire. Or we would, if our fire extinguisher runs out of extinguishing material and the fire is not out, then we would want to immediately follow our evacuation route to exit the building. And then lastly, we only want to use a fire extinguisher at the incipient or the beginning stage of a fire. We never want to ourselves or encourage employees to try to fight a fire that is already beyond the beginning stage. At that point, everyone should be instructed to follow the emergency action plan, evacuate the building, and 911 or your emergency number for your fire department should be called. Okay, we went over, just to reiterate again, the PASS technique. Pull the pin allows you to discharge the extinguisher, aim at the base of the fire. This hits at the source of the fuel. If we aim at the flames, the extinguishing agent just kind of flies through it and doesn't get to the source of the flames and does not help us. The first S is squeeze the handle after we've got it aimed at the base of the fire. This helps to press the button, and it releases the pressurized extinguishing agent. And then lastly, we want to continue to sweep from side to side while the extinguishing agent is being dispersed from the extinguisher. We want to stay in the area to make sure the fire is out and does not reignite. As we saw earlier, especially with Class A materials, like I've seen in at workplace a large dumpster that had caught on fire that was put out and kept reigniting for several days, actually. So they that company had to keep a constant watch on it, and they had the fire department involved, and it was still kept reigniting. Okay, so rules for fighting fires. As we all, I think, know, fires can be very dangerous. We should always be certain that you will not endanger yourself or others when attempting to put out a fire. I always instruct employees to ensure that you know where your closest emergency exit is. If you are attempting to fight a fire, make sure that you have a clear path to it and are quickly and easily able to access it if your fire extinguisher runs out of extinguishing agent or the fire gets beyond beginning stage. Because we can replace anything in a building, we can replace things, but we cannot replace people. And so the utmost importance is to protect all of ourselves and all of our employees in our area or in our company. So if a fire is discovered, we want to assist any person in immediate danger to safety. Only, try to do this if it does not cause risk to yourself. You may need to get help from others to do so, but we want to make sure everyone is safely evacuated out of the building, except for those that may be designated to fight a beginning stage fire. But either way, someone else in your emergency response plan, this should be identified as to who is responsible for calling the fire department. Some large companies have their own fire department on site, or it might be your community fire department. Another option is to activate the building fire alarm. Many times the building fire alarm is designed to notify employees that there's a fire and we need to evacuate, but also they're designed to notify the local fire department. They also might cause water to turn on and to come water to be showered down if it's an area where that can be utilized. So these can be designed to do a lot of things, but we want to make sure that we understand how our fire alarm is designed. We want to make sure that it does notify the fire department. If you're not sure if it does, then you want to make sure that you are also calling the fire department or someone that is designated as responsible to do that, so we ensure that the quick notification occurs. Again, if the fire is small, you may attempt to use an extinguisher to put it out. But before deciding to do that, again, make sure you know what it is that is burning. We've talked a lot today about we have to know what type of material it is. That tells us what class of fire it is, and that tells us what type of extinguisher to use. So it's very important everyone knows what the chemicals are, what the dangers are. If it's in a certain area that could produce a toxic fume or a potential something could explode, we just need to evacuate everyone from the building and let the fire department handle the situation. As I mentioned earlier, I always encourage employees to, if they are planning to attempt to fight a fire, know where your emergency exit is, and then always position yourself to where you can quickly escape or quickly access that exit. If you'll notice, but this is by design, that many fire extinguishers are located near emergency exits. And that is so that we have to get to that emergency exit to get the fire extinguisher, so then we know where that emergency exit might be. And you only want to go back close enough to the fire to where your extinguisher can reach it, but you want to, always consider your own personal safety and the safety of others first. Again, in case the fire extinguisher malfunctions, runs out of extinguishing material, and the fire is not extinguished, then you want to have that clear route to get out, and so that you don't become trapped in the building. You never want to attempt to fight a fire if you don't have the adequate equipment or the appropriate equipment. Again, if it's beyond a beginning stage fire, I do not recommend attempting to fight it unless you are a part of a trained fire brigade within your company. And OSHA's standard related to fire brigades, meaning like a private firefighting group on a company property, those employees must be trained to the same level as a local fire department. So you would have to have all of that equipment and all of that training. You also do not want to attempt to fight a fire if you have inhaled toxic smoke. And that could be something as simple as foam padding from carpet or a sofa. Those synthetic materials can be hazardous for you to inhale. So ensure that your attempt to fight a fire does not put your health at danger. And your instincts are key here. So if any employee feels unsure or uneasy about fighting a fire for any reason, I strongly suggest that everyone evacuates the building and calls the fire department to allow them to handle it, because that's their job. That's what they're equipped to do. Okay, and that is our presentation for today on the OSHA standards for fire prevention and fire emergency response. Thank you for your time.